Iterators and generators are crucial for efficient data handling in Python. Iterators allow sequential data access without loading the entire dataset into memory. Generators, on the other hand, enable lazy evaluation, producing items only as needed. This approach optimizes performance, especially with large datasets, by reducing memory usage and improving execution speed. Python's iteration is built on two key concepts: iterables and iterators. Iterables, like lists and strings, implement the double underscore, I double underscore, R double underscore, T double underscore, E double underscore, T double underscore, E double underscore, L double underscore, M double underscore, E double underscore, T double underscore, H double underscore, O double underscore, D double underscore, E double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, R double underscore, I double underscore, M double underscore, P double underscore, L double underscore, E double underscore, M double underscore, E double underscore, T double underscore, H double underscore, O double underscore, D double underscore, E double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O double underscore, W double underscore, L double underscore, O double underscore, P double underscore, E double underscore, N double underscore, T double underscore, H double underscore, O
double underscore W double underscore L double underscore O double underscore P double underscore E double underscore N double underscore T double underscore H double underscore O double underscore W double underscore L double underscore O double underscore P double underscore E double underscore N double underscore T double underscore H double underscore O double underscore W double underscore L double underscore O double underscore P double underscore E double underscore N double underscore T double underscore H double underscore O double underscore W double underscore L double underscore O double underscore P double underscore E double underscore N double underscore T double underscore H double underscore O double underscore W double underscore L double underscore O double underscore P double underscore E double underscore N double underscore T double underscore H double underscore O double underscore W double underscore L double underscore O double underscore P double underscore E double underscore T double underscore H double underscore O double underscore W double underscore L double underscore O double underscore P double underscore E double underscore N double underscore T double underscore H double underscore O double underscore W double underscore L double underscore O double underscore P double underscore E double underscore N double underscore T double underscore H double underscore O double underscore B double underscore L double underscore double underscore double underscore double underscore double underscore double underscore H double underscore B double underscore L double underscore O double underscore P double underscore E double underscore D double underscore H double underscore B double underscore L double underscore O double underscore B double underscore E double underscore T double underscore H double underscore O double underscore B double underscore L double underscore B double underscore T double underscore H double underscore O double underscore U double underscore L double underscore O double underscore D double underscore D double underscore H double underscore O double underscore U double underscore L double underscore O double underscore B double underscore E double underscore T double underscore H double underscore O double underscore U double underscore L double underscore O double underscore E double underscore E double underscore T double underscore H double underscore O double underscore U double underscore L double underscore O double underscore B double underscore E double underscore T double underscore H double underscore O double underscore U double underscore L double underscore iterators with both iter and next methods traverse these iterables, maintaining state. When elements are exhausted, they raise stop iteration, signaling the end of traversal.
Iterables are objects like lists, tuples, and strings that you can loop over, thanks to their double underscore iter, double parenthetical left bracket, double underscore iter, double parenthetical right bracket method. Iterators, on the other hand, have both double underscore iter, double parenthetical left bracket, double underscore next, double parenthetical right bracket, and double underscore next, double parenthetical right bracket methods, allowing them to traverse iterables while maintaining state. They raise a stop iteration exception when no elements remain, indicating the end of iteration. Python's for loop initiates by calling the iterable's iter method, obtaining an iterator. It then repeatedly invokes the iterator's next method to access each item. When no items remain, the stop iteration exception is caught, ending the loop seamlessly. This process ensures efficient and controlled iteration over data structures. Creating a custom iterator class involves defining the double underscore I double underscore E double underscore R method to return self, making the object its own iterator. Implement the $n_e_x method to return the next item, using an index counter to maintain state. Raise stop iteration when the sequence is exhausted, as demonstrated in the countup class example. Generators in Python offer a streamlined way to create iterators. By using the yield statement, they produce values one at a time, pausing execution between yields. This lazy evaluation allows for memory-efficient handling of large datasets. When invoked, a generator function returns a generator object, enabling deferred computation and efficient iteration. Generator functions utilize the yield statement, altering execution by producing values lazily, one at a time. This approach pauses execution between yields, optimizing memory use for large datasets. Instead of executing immediately, they return a generator iterator object, allowing deferred computation and efficient data handling. The yield keyword allows functions to pause execution and return a value, preserving local variables and the instruction pointer. This enables the function to resume from where it left off, maintaining state across calls. This model is efficient for handling large datasets, as it avoids storing entire sequences in memory. The countup function exemplifies generator syntax, yielding numbers sequentially from 1 to n. This approach is memory efficient, generating values on demand without storing the entire sequence. Its simple syntax is more concise than a full iterator class, and it allows for flexible range generation, accommodating both finite and infinite sequences with minimal code changes. Iterators are class-based, requiring explicit state management with _iter, double parenthetical left bracket, and _next double parenthetical left bracket methods, leading to verbose code. Generators, however, use functions with yield, automatically saving state and offering concise syntax. They excel in memory efficiency, especially for large datasets, making them ideal for most iteration tasks. Generators shine in real-world applications by offering performance and memory benefits. They efficiently handle large datasets, such as reading massive CSV files line by line, preventing memory overload. This method ensures scalable processing, maintaining a constant memory footprint regardless of file size, making them ideal for data-intensive tasks. Generators efficiently process large files by reading them line by line, preventing memory overload. This method is crucial for multi-gigabyte datasets. For instance, a CSV, comma-separated values file can be read using a generator, processing each line individually. This ensures scalable processing and a constant memory footprint, regardless of file size. Generators allow for the creation of infinite data streams, such as the Fibonacci sequence, without memory overload. By yielding values one at a time, they efficiently handle sequences of unlimited length. This approach ensures only the current value is stored, maintaining a clean and natural syntax for expressing mathematical sequences. Chaining generators allows for creating efficient data processing pipelines. Each stage, like reading numbers, filtering evens, and squaring, is modular and reusable. This approach supports lazy evaluation, processing data on demand, and maintains low memory usage by holding only one item in memory at a time. Advanced generator concepts enhance programming by enabling coroutine-like behavior. These features allow for more sophisticated data processing patterns, such as cooperative multitasking and asynchronous input-output operations. By leveraging these capabilities, developers can create more efficient and responsive applications, optimizing resource usage and improving performance in complex systems. Generator expressions offer a memory-efficient alternative to list comprehensions by using lazy evaluation. They employ parentheses instead of brackets, allowing for single-pass iteration. This makes them ideal for large data transformations, as they consume less memory by generating items on the fly rather than storing them all at once. Advanced generator methods like send, throw, and close transform generators into coroutine-like constructs. The send method allows two-way data flow by sending values into the generator. The throw method injects exceptions for error handling, while close gracefully terminates the generator, ensuring resource cleanup. Asynchronous generators in Python 3.6 Plus leverage async/await for efficient I/O-bound operations. They enable non-blocking network and file input/output, ideal for event-driven programming. For instance, using AIOHTTP, async generators fetch web pages concurrently, processing thousands of operations with high throughput. This approach is perfect for handling multiple concurrent streams efficiently. Generators offer significant memory efficiency, using 380 times less memory than lists for 10 million integers. This is due to their ability to maintain only the current state, ensuring constant space usage. In contrast, lists grow linearly with data size, leading to higher memory consumption. This efficiency translates into improved execution performance, especially with large datasets. Generators significantly reduce memory usage compared to lists, especially with large datasets. While lists store all elements, generators maintain only the current state, using 380 times less memory for 10 million integers. This efficiency is due to generators' constant space complexity, O1, versus lists' linear growth, ON. Generators offer immediate value production, making them 8,500 times faster to initialize compared to list comprehensions. This efficiency is crucial for large datasets, where time to first value is critical. Despite a 3% iteration overhead, generators maintain superior performance, especially when handling extensive data ranges. Debugging generators requires specialized techniques due to their lazy evaluation. Use NextGen to advance generators step-by-step and ITER for inspection. Access internal state via gen.gi_frame attributes. Implement logging strategies by inserting print statements to trace execution flow and yielded values. These methods enhance understanding and debugging of generator behavior. Consolidate your understanding of iterators and generators by applying best practices in production Python code. Focus on leveraging lazy evaluation, maintaining state efficiently, and utilizing advanced features for robust, scalable solutions. Iterators provide a universal interface for sequential data access, enhancing Python's for-loop syntax. Generators simplify iterator creation with yield statements, reducing boilerplate and managing state. They excel in processing large datasets and infinite sequences through lazy evaluation. Advanced features like send and async generators enable powerful patterns for concurrent programming. Refactor traditional loops into generator-based solutions to enhance efficiency. Apply generators to real-world datasets, leveraging lazy evaluation for optimal performance. Compose generators into memory-efficient processing pipelines. Solidify your understanding through coding exercises and quizzes. Embrace generators for scalable, clean Python code, suitable for both small scripts and large-scale data processing.